So yesterday we talked about probability. We talked about two different things. Okay, phones away, you guys. Let's go. Focus here, right? All right. Pretty sure when Josh is at the ACC next to taking cooking, they're going to say phones in the lockers, not allowed to kitchen.
Or you use it as a cutting board.
Or what? I would not use your phone as a cutting board.
No, just like on safety, right?
No, I would not use your phone as a cutting board. Okay. So yesterday we talked about basic probability. We talked about theoretical, which is like the theory part. Like if there's like 6 outcomes, like say for example, maybe you're rolling a die, right? You got like a 1 in 6 chance of getting a 3 because there's 6 possible outcomes, and there's only one that's favorable. That's the 3. And then there's experimental, which is where you do an experiment to find out what the chances of something are, right? Okay, so now we're going to sort of go a little bit further and talk about expected value. So probability can be used to find expected value, or EV. Expected value can help us predict winnings or losses. Frequently used by insurance companies and businesses. Okay, so this is not just a made-up math thing for teachers to annoy students. Robert, you should take those earbuds out so you can hear me. Odie, you should take that toque off. Josh, you should take your hood down. Excellent. So in many games, you pay a given amount to play, right? Sometimes called an ante. I don't think I've seen that in the curriculum, but sometimes called an ante. Like if you're in Vegas, you have to ante up, or you may even have heard that term, ante up. Right? It's how much you have to pay to play. If you win the game, you receive a payout, but is the game worth playing? Does the amount you could win sound too good to be true? For example, I said yesterday that the odds on 649, I think I said 1.13.3 or 50.9 million, something like that, right? What are you expected to win? Well, millions and millions of dollars. What's the cost? The $1 that you pay, or the $2 that you pay for the ticket. Are they $2? I think they're $2, right? I never buy those. I buy the scratch ones because they're simple. I don't have to check them.
Yeah. You know, right then and there, if you've won or lost.
Yeah. Well, you know you've lost.
Well, yeah.
And even if you do win, you put them on your fridge and forget to cash them in. Okay, so we're going to try this here. Okay, Bodie, please. Oh my goodness. You need to repeat this activity as many times as needed until a definite pattern becomes clear. So one person will act as a banker and have 15 of the pennies. So I got to get the stuff here for you. The other person will have 10 pennies. The player must pay the banker 1 penny each time the game is played. If the player draws a spade, the banker pays them 3 pennies. Play for at least 10 games. How much money does each player have? So I'm going to say we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, perfect. No, I want you to play. Let's go groups of 4, but one group of 3. So gather your. Oh, well, maybe Miss P, you could be a. We'll go groups of 4. You can be the banker in one group. Okay. We'll do groups. So groups of 4, and one group can have Mrs. P as the 4th. Okay. You might not have this in your package. Would you play this game with money?
No. Yeah.
Chris might, but generally no. Does the player have much of an expectation of winning? Elvis said right away, this game is rigged. You just felt it, right? I'm going to prove to you just how rigged it is. Okay? Do you have this in your notes? So, expected value is an estimate of the average return or loss you have when playing a game of chance. So it's what you can expect to win or lose. Some cases, you might beat the odds, like Chris did, and you end up winning, right? Okay, now the formula that was originally given, I don't like. Okay? So I'm going to say, put this in your spot here. I'm going to say expected value is equal to P-win. P-win stands for the probability of a win times what I'm going to call the gain, sometimes called the payout. And that's in brackets like that. Probability of a win times the gain plus, more brackets, probability of a loss times the ante, or what you have to pay. Okay, probability to win times the gain or payout, plus the probability of loss times the ante. So in this case here, we'll work this out right away here. The concept of expected value can be used to determine whether you should play games of chance, or it's rigged towards the dealer. This game was rigged. Bennett Casino is going to be the winner, as is every casino. Okay? As is every lottery. That's the way it works. Insurance is really a reverse lottery. It's a lottery you hope to never win. Home insurance. When you buy home insurance, right? You don't buy home insurance hoping that your house will catch on fire and burn to the ground to get the money. You buy it in case, right? It's kind of a reverse lottery. But insurance companies operate the same way. They rig the game so that they win. They make money. You lose money. Every year you lose your premium on the chance that you might have your house burned down. Okay, using the game from the activity, find the expected value of the game. So, what is our gain here? You have to figure this part out. What is the gain or what is the payout? Right? How much do you win in that game? How many chips did you get? 3. You win 3, but it costs you 1. So the payout or the gain if you win is 2. That's an important step. You have to make sure you do that. Right? So you take your winnings minus the payout, or the pay, the ante. Okay, so now, why so much language? Probability of the win. What is our probability of a win here? How many spades are there in the deck, Bodie? You knew the answer? 13. How many in total? 52. So the probability of a win is 13 out of 52. Robert, why are you looking at your phone? Probability of win is 13 out of 52. And you multiply that by your gain, which is 2. Okay, so get out your calculator. You're going to go 13 out of 52, which is 0.25, by the way. Why 0.25? Or quarter? How many suits are there in a deck? 4. You're winning if you get spades. 1 out of 4. 13 out of 52 is really just 1 out of 4. 25% chance of winning. Boy, take 2 copies. 0.25 times 2. 0.5. But we're not done. We have to add the probability of a loss. You still don't have that? Oh, you don't have the book in there from yesterday. Yeah, right here. What's the probability of a loss here? If it's, Bodie, why do you still get your 2 coming? If the probability of a win is 13 out of 52, how many cards are losers? Lots. 52 minus 39. Sorry, not 50. 52 minus 13. Right? 52 minus 13. There are 39 loser cards. Sorry if I offend the cards by calling them losers. There are 39 loser cards. So the probability of a loss is going to be 39 out of 52. How much do you ante? $1. Right? So 39 out of 52 times 1, of course, is now. But it's not plus 0.75. I forgot to mention this, right? This number here, your payout has to be negative. Why negative? Because you're losing, you're paying it out, right? So this is really plus a minus 0.75. So your chances of winning, 13 out of 52 times 2, 0.5. Chances of losing, 39 out of 52 times minus 1, minus 0.75. And when you add those together, 0.5 minus 0.75. Your EV value, your EV is minus 0.25. You can expect to lose 1/4 cent every time. Now, some people might win. Chris won. They beat the odds. But if you played it over and over and over and over, you're going to lose. How much would you expect to win or lose if you played 100 games? 100 times minus 0.25, or minus 25 cents, minus $25, depending on what your ante is. If you're playing for dollars, it's dollars. Right? The casino can expect to earn $25 for every 100 hands played. And if you've got 1,000 people playing, who's making the money? Mr. Casino Order. You little players don't have a chance. What do they do in Vegas to try to encourage you to keep playing? They do. They give you free drinks. Yep. They maybe some snacks. They might even give you they might even say, you know what? We'll give you a complimentary room, right, to make you stay overnight. They do all those things. Why? To make you keep playing, because they know that in the long run, they're going to win. They're playing the long con, Robert. Don't fall for it. Yeah. Don't fall for it. Have I ever gone to Vegas? I have. I have. I have. A couple bucks. Because I know the math. I know the math. The longer I play, the more I'm going to lose. I just played for fun a couple times. I'll tell you a story, though. I'll tell you another bet. Okay, so you can expect to lose minus $25. Here's a little cartoon for you. Do you guys have this?
No.
You guys know Dilbert, the cartoons? The comics? People don't read comics anymore, really. Dilbert says, the best way to make this decision is by calculating the expected value of each possible outcome. You multiply and this is the boss. The boss says, must pretend to be dead. And Dilbert says, I sense that we're done here. And the boss says, I hope the dead sometimes cover their ears. Doesn't want to hear it. It's not that funny. Dad jokes, yeah. Okay, here's another example. This is a business-related one. Okay? Do you guys have this? Robert, did you find it?
Yeah.
Okay. You should, on the next page. Example number 2.
Yes.
Okay. Robert, why do you have the earbuds back in your ears? Based on past experience, a building contractor estimates that the probability of winning a contract is 0.3. So maybe there's a builder. Like when we had renovations done to the school, we put the windows in, there would be various builders that would bid on the contract, right? One of them's going to win, the others are going to lose. So this person thinks that the probability of winning a contract is 0.3, or I guess you could say 30%. What's up, Josh? Okay. The contract is worth $25,000 profit, and she knows it will cost $2,400 to prepare a contract proposal. So the hours spent putting it all together is going to cost her $2,400. Find the expected value of the contract proposal. Is it a financially good idea? What other factors might you consider before making a decision? Where do I have space for this? I don't. I got blank space. Okay, so first of all, let's figure out the gain. How much does the contractor stand to gain? Well, there's a profit of $25,000, but it's going to cost Bodie how much? $2,400, right? So this is the gain. The gain is $22,600. Again, important step. If you screw that step up, it's going to throw your expected value off. Okay? Now, there's not a lot of space there, right? Right small. What's the probability of a win? What did they say in the question? 0.3 or 30%, right? 30% chance of winning. Now, they don't come right out and say it, so you have to figure it out. What's the probability of a loss? If it's 30% win, 70% loss, Robert. You're right. So really what you do there, I'm going to specifically say I'm going to write 100 minus 30. 100 minus 30. 70% loss or 0.7. You got to have it as a decimal. You have to figure out the odds of losing. Bodie, are you with me here? You look like you're on your phone now. No? It looks like you're on your phone. No? Okay. Just the way your hand was, I couldn't see. Okay, so the expected value is going to be the probability of a win, 0.3 times the gain, 22,600. Right? Everybody with me? Plus the probability of a loss, 0.70 times the ante. What's the ante in this case? How much does it cost you? 2,400. But remember, it's negative. If you screw that up, that always has to be negative. You'll never lose if that's not negative, right? This is really a lot like those. Remember when we did weighted averages? If you stop and you really think hard, you might realize that this is virtually the same. Okay, so now we got to do the math part. So 0.3 times 22,600. I get 6780. Did you get that, Robert? So 0.3 times 22,600 is 6780. Plus, and this is going to be, can we just drop the plus? Because we know it's going to be negative, right? Yeah. We know it's going to be negative. So that's going to be 0.7 times 2,400 minus 1680. And then you just add them together, and you get $5,100. The expected value is $5,100. If the contractor were to bid on this contract over and over and over, she could expect to win some and to lose some, but overall she would average $5,100 profit in return. Is it financially a good idea? Yes. The EV is positive. If the EV is positive, it's rigged towards you. If the EV is negative, it's rigged away from you. Okay? Yeah. The EV is positive. Are there any other factors that she should consider before making the decision? Well, is the 0.3 accurate, or is that just a wild guess? Like, if she doesn't know that for sure, she's gambling on that 0.3, isn't she, right? Yeah. Is the 2,500 accurate? Put 0.7 times 2,400.
Negative.
Yeah, negative. 0.7 times 2,400. Yep, 1680. Geez, down to the math, eh? Okay, there's some practice problems there. I kind of get the feeling that I should do that table one first.
Yeah, maybe.
Do you want me to do that practice table one first?
Yeah.
Or do you want me to let you try it and then we're kind of run out of time here? You know what? Here's what we'll do. I'll let you guys try the practice problems. I'll give you the answers to the practice problems tomorrow, and then I'll give you time tomorrow to work on both these assignments. How's that sound? Okay? So I'll try those practice ones today. I'm kind of tired of talking.